multiplication and division. Don't forget they are inverse operations, opposite operations, just the same as addition and subtraction are inverse operations. All right, so before we get to the meat of the lesson, I just want to remind you or make sure you know the different symbols that represent multiplication. Here's one. The little x means times. Another one might be 5 times 2 with a dot. You see that? It means to multiply. Can you think of any others? Okay. Parentheses, yes. So 5 times 2 in parentheses. If there's parentheses side by side, no symbols in between, that is an indication to multiply. Even without that symbol, you could have the 5 outside the parenthesis and what you want to multiply by inside the parenthesis. So I'm going to multiply 5 times whatever's inside here, 2. A number beside a parenthesis with no symbol in between also means to multiply. So, good review on that. And then, division symbols. This is one, obviously. Another one you might see is the long division symbol. So 10 divided by 2 would look like this. 10 divided by 2, because 2 is your divisor. Goes outside the long division bar. Or you might see 10, this fraction bar also means divide. So 10 divided by 2 is also another way. Very good, very good. All right. Another thing I want to cover when we're reviewing multiplication and division, or what are these called? When you're multiplying, these are called, anyone know? Factors. Well, that's a factor times another factor gives you I forgot. Oh yeah, product. I haven't had my coffee yet this morning. These are the vocab words that go along when you're talking about multiplication. A factor times a factor equals a product. While we're here for a second, 5 times 2 is 10 and 2 times 5 is 10. Just like adding, factors can come in any order and still give you the same product at the end. All right, division and subtraction, they kind of have a different rule. Order matters. So they have different names. They're not the same thing like factor, factor, addend. They have to get a different name because each of their parts has a different role to play. So this one's called the dividend. Dividend is always divided by the divisor, and it ends up with a quotient. Your answer to a division problem is called a quotient. So I know those hopefully are review. If not, get them in your memory right now. The number, the dividend, when you're whatever you divide by is your divisor. Right here I'm dividing by 2. This divisor's outside here, and this is divided by the bottom number's your divisor. FYI, kind of need to know that sometimes. Okay, the next thing I'd like to talk about with multiplication and division is the patterns we might see. You see 5 times 2 is 10, and you can switch those around. 2 times 5 is also 10. And then 10 divided by 2 is 5. Well, if we replace these two last numbers, just like in subtraction, 10 divided by 5 is 2. So they have similar pattern to adding and subtracting. We'll see how we can use that to solve problems. What times 2 equals 10? Well, we know the answer. But if you didn't, what if these numbers were bigger and you're like, I better figure it out? How do you figure it out? Which one of these patterns can you use? Pick an inverse operation and say 10 divided by 2 would give me 5. Instead of times, we divide to get the answer. Same thing here. 5 times what equals 10? Well, 10 divided by 5 will give me the answer. So to solve these multiplication problems, we do the inverse operation. Pretty straightforward. Undoes the problem, works backwards to get us the original. That's missing. Okay, but this side, let's take a look. 10 divided by what equals 5? I don't say times to get the answer here. I don't do the inverse operation. Because order matters, you have to say, look at the pattern. If 10 divided by 2 is 5, 10 divided by 5 would give us 2. And that's what we're looking for. So instead of saying divide by, you take the other quotient, I guess you take the quotient and reverse the last 2. This is the pattern for solving this particular missing number. But then when you come to this one, This one wasn't an inverse, but let's check out this one. Is it? I don't know. Something divided by 12 will give you 2. This is a new example. These numbers don't match here, but I want you to use these to help you solve. So, if you notice, the bigger numbers here divided by into parts gives you a smaller number. So, if I'm dividing by 12, this number here is going to have to be pretty big, so I can divide by 12 to get 2. So I'm wondering if I'm going to have to use an inverse operation. Instead of dividing by 12 to get 2, I could work backwards, do the inverse, and say 2 times 12 gives me 24. So yes, on this one I need the inverse operation because 24 divided by 12 gives me 2. This one's the only little interesting case. The straightforward ones when this one's missing. So, keep an eye out for that and don't get confused. Otherwise, the inverse operation is your best friend. We're about to turn to page 18 and try a few of these out just to make sure we know when to use the inverse operation and when not to. So, let's do this.